Hello, hi, my name is Mohammed Afzal. I'm engineering architect at Cisco. Today I'm going to show you Cisco UCS integrated infrastructure with Cisco ACI solution. It is based on Red Hat OpenStack Platform 8, which is the Liberty release of OpenStack. The white paper is already out there. As you can see the link, the more detailed information is available in this white paper. As you can also see the topology that involved the components with respect to networking, compute, and storage. And Cisco UCS B200 M4 service providing controller and compute to the environment, and Cisco UCS C240 M4 is providing Ceph storage. And also Cisco Fabric Interconnect ST248 has been used in this solution. And also the ACI network is comprised of 9372, Cisco Nexus 9372 as a leaf switch, and Cisco Nexus 9336 as a spine switch. APIC controller are also used and are connected to the leaf switches. Now let's take a quick look at the OpenStack side. This solution leverages ACI plugin to orchestrate OpenStack related, Neutron related activities within ACI environment. So let's have a demo on the ACI plugin. First, take a look at how things are laid out inside ACI environment. Let's log into the API controller. Click on the tenant tab. All the OpenStack project are mapped as a tenant inside ACI environment, followed by the system ID that we have specified inside ACI configuration file. For example, here OSP8 APIC is the system ID that we have specified. And this is the admin tenant. If we go into the admin tenant, if we start browsing things inside it, for example, networking, as you can see that the Neutron network has been mapped as a bridge domain. These are already created network. We will create some brand new networks in this demo. If we further drill down, we can see the subnet, which is the subnet for the Neutron network. And .1 address is shown as the Anycast gateway, which is acting as an SVI, like a classical switch. And also under application profile, EPG has been created for the same networks. So let's quickly take a look at networks in OpenStack environment. Let's quickly go to the OpenStack topology, network topology. So if we take a look at it, there are two networks we talked about earlier, Net2 and the Net11. As you can see, that has been created under admin tenant, Net2 and Net11. And these two networks are connected with the router 1. Routers are usually mapped inside ACI environment as a contract under common tenant. So if we go to the common tenant, if we expand the security contract, and you can see that if we try to match this router ID 9AE, so if you click on that router, that 9AE, and you can see that, this router is connected to two private network and also to the L3 out, providing external connectivity to the environment. So if you click on the contract, the same contract, you can see that it is connecting the Net11 and Net2 EPG and also L3. L3 out is also configured under common tenant. If we expand the networking and we go to the external routed network, L3 out is configured. L3 out configuration is independent of OpenStack. It can be configured based on the environment by using OSPF, EIGRP, or static routing. Make sure that it is working before you start using it within OpenStack environment, that you can reach out. And once it's configured properly, an external network can be provisioned inside OpenStack environment, just like it is created here inside an OpenStack environment. So it provides external connectivity to the VM, and this is further connected to the external router to go outside. Let's start creating some network and see how things are orchestrated and automated within ACI environment via the ACI plugin. So let's create a network. We're going to name it as a demo net, and then let's quickly create a subnet here. And give an IP 192.168.3.1.3.0/24. You can also provide allocation pool in the DNS name server. Let's hit create. So now the network is being created. Now look at things around ACI. If we go into the admin tenant and we expand the networking, we should be able to see the newly created network demo net. And as you can see that the subnet we specify, we also created an SVI inside ACI environment. If you expand the application profile, we can also see the EPG for that network. So look at the topology again. Demo net is here, and now start provisioning some VM and attach to this demo net. Launch an instance. Instance can be launched from various locations within the dashboard and also through OpenStack CLI. But the mapping will remain the same because it calls the same OpenStack API, and the ACI plugin will perform the same functionality. Let's give a name, a demo VM 1, and then create a new volume from an image and delete that volume once the VM is terminated, and attach that volume to the VM, and also this VM should be connected to the newly created network. Let's hit launch. The VM is being currently launched and currently being provisioned. As you can see that a VM has been created with the demo net connected to the demo net, and the demo VM1 has been created. If we click on the demo net EPG and also hit the operational tab, we can see that endpoint demo VM1 has been created. That's the MAC address of the VM, and it also shows where it has been created. It is created under Overcloud Compute Node 2. Let's take a look at it. What's the situation of the VM? It's currently being available to log in. It's currently being provisioned to get an IP address on the DHCP server. Now the VM is ready. Now we can log in. It has been given an IP 192.168.3.5. Now look at APIC. As you can see that the IP has been also visible. IP is also visible in ACI side. If you look at the network in the OpenStack side, and if we try to, let's open a VM in any of the other network, for example net2, VM net1. Let's open a console for this VM. This VM has an IP of 192.168.2.9. If we try to ping that VM from our demo VM, we will not be able to reach that because there is no router connectivity. let's create a router interface and connect this demo net with this router. Add interface. Before we do that, let's go to the common tenant and take a look at the contract for the router. It's under security policies, contract, and this is the router. Add interface. Once we add an interface, as you can see that demo net 1 is also connected to the same contract. So now we have the connectivity to net 1.1, net 2, and also L3 out through this contract within ACI environment. And now you can see that this network is connected to the router 1, and this router 1 is connected to other networks. Let's see what's the situation of the VM that we started a ping, and now see that ping is already successful. And that should be able to ping the other VM as well. 192.168.3.5. So now what the VM can communicate to each other via the neutron router. And the demo VM should be able to reach the L3 out SVI as well. Let's take a look at how the SVI has been configured, how the L3 out has been configured under common tenant, and we are trying to reach the external gateway. So if we expand the networking and external routed network, there is a bridge domain for external routed network as well under application profile, and there are two subnets within the bridge domain. So now let's expand everything. After connecting to the router, we should be able to reach to these subnets as well from our demo VM. .1.3.1. As you can see that we can reach the L3 out. There is another network that has been created inside OpenStack network environment, which is SNAT network. What this network does is it provides OpenStack and Cisco ACI to process SNAT traffic for VM that do not have floating IP. So this network can provide a floating IP to the VM 10.1.3.1, but this is the SNAT network that actually provide external access without a floating IP. Off-flex system automatically assign SNAT IP to each computing host from the host pool CIDR that we specify in L3 out configuration file, which is ml2_conf_cisco_apic.ini. Subnet for L3 out and SNAT are created in the external bridge domain, as you can see, under common tenant. So if we try to ping that IP, which is the SNAT gateway IP from the VM, we should be able to reach that as well. As you can see that. And if you want to assign a floating IP to this VM, it will be assigned from this IP subnet. SNAT allowing VM to go outside without assigning a floating IP is useful for providing outside access to the VM. Use cases could be for operating system level updates. That's all for now. Thank you for watching this video.